Go ahead.
Yeah, thanks. Hi, I'm Sonali, and our topic is generative AI and machine learning in healthcare. I'm using slides from another conference, Data Science Salon, and I hope that's okay. So I will start with, so people come from different backgrounds in this group. So I'm going to start with just an overview of nonprofit healthcare ecosystem. I work at Fred Hutch Cancer Center. Then we'll warm up with this example of regulatory chatbot. And I want to spend most of the time today on the sickle cell project, and then a little bit about future directions. So at Fred Hutch, so just to give you some background, so it is a cancer center. We have world-class expertise in oncology, but also we do infectious diseases and benign or classical hematology, which is non-malignant blood disorders. So sickle cell is one of them. Also, just some history of the organization. We used to be two separate organizations. There was a Fred Hutch Cancer Research Center and a separate entity, Seattle Cancer Care Alliance, which was the care delivery branch. So a couple years ago, we merged to form Fred Hutch Cancer Center, which is now the cancer branch of University of Washington Medical Center. So we have 3 Nobel Prize winners in many countries where we do research, over 5,000 employees, a big campus, 50,000 plus patients served annually. We also do screenings and clinical trials. So enterprise, so I sit within what is called enterprise analytics, or now one of the things that has changed since last November is now we are clinical analytics, because we truly sit on the clinical side. So the research use cases are supported by the respective lab resources. So they will have the fund, they'll be funded by their research grants. We sit on the care delivery side. So we provide support for operational, strategic, and clinical use cases. So our work is under quality improvement umbrella. So we don't do IRBs and so on, because our work is directly for the benefit of the patients, and I'm swimming in PHI. Like all of my data essentially is patient data. The enterprise analytics team or the clinical analytics team, I'm the only data scientist on the team. The rest of the team is analysts. So most of the team will be building dashboards, tracking key performance indicators or other quality indicators. So the tools that they're typically using, it's SQL and Tableau. Fred Hutch uses EHR system, electronic health record system called Epic, which is I think the biggest EHR. This also we switched a couple of years ago, so lots of changes in the organization. So we also have Epic analysts who have deep expertise in the EHR system itself. And we also have an educator who helps clinicians access information using Epic reporting tools. So Epic, the EHR itself, provides a lot of kind of self-serve tools. So our educator kind of helps clinicians work with those workbench reports and so on, where you don't even need to use SQL or Tableau. Like there is already some visibility into the data. We also have clinical notes in our SQL data mart. A lot of the data, like say, for example, your lab results or something, will be available in structured format. But then there are other pieces of data about the patient that are not available in these discrete fields. So sometimes you may need to dig into the clinical notes to get some information out. And that is part of what I can do. Another thing to keep in mind in healthcare system is that our partners are typically clinicians who are actually like they are spending their time helping patients, right? So sometimes work with data or these kind of projects can take a back seat. Also, since November to now, another thing is that our infrastructure can be limited, and because it is PHI work, it is very, very important that we do this right. So sometimes that becomes a bottleneck, that, for example, I've not been able to move this project forward at all since last November because we don't have the infrastructure. So there are some of those limitations. So the goal I have is to use these advanced analytics tools, including NLP, machine learning, to support business partner endeavors. Uh, so let's warm up with this regulatory chatbot use case. I picked this first because this does not have any PHI. So because our infrastructure, like, we need to be very careful dealing with PHI. So this was a good kind of learning case for me, or an experimental case for me. So to give you some background, we all know that healthcare regulations are very complex, right? And for a very good reason, that this is a, if I go to a hospital, I want to know that somebody is, like, making sure that everything is up to standard. So there are very good reasons why they exist. However, they are extremely complicated, right? So, like, this information from the American Hospital Association highlights just how complicated. So hospitals must comply with some 629 discrete regulations, and they spend a lot of money doing this. There are a lot of people working in this field. So Fred Hutch also, of course, has to comply with these regulations, and we have a regulatory compliance team. So this work was with our regulatory compliance team. The goal was to look at a whole bunch of regulatory documents, and to make it easier for our team to get information out of those documents. So in general, when I work on projects involving this generative AI, my philosophy is that these will make very good, like, these are adroit assistants, but we should not look at these as omniscient oracles, right? So they can't be the ultimate word. These are, we can develop tools that will make the work easier for humans who should ultimately be in control, especially in healthcare and these important areas like regulatory compliance. So the goal was to create a semantic search based tool to identify references for our team. So we started with the domain experts. So always in these kind of use cases, you have to work very closely with business partners. I worked with the domain experts to identify the documents that they wanted to look at. And because these documents are in the public domain, I didn't have to worry about privacy issues for this project. So this step, like, for example, like, you can always have, like, now, for example, you have direct conversations against PDFs, but this step, in my eyes, adds great value, because then you can standardize, you can make sure that you're looking in the correct place according to the domain experts. So based on the PDFs that they identified, and this is the standard process, like, I created a vector store. So you first take the PDFs, split them into chunks, and then create a vector store. I used Fires and LangChain with the All-Mini LM L6v2 embedding for this project. And this was hosted on Hugging Face at some point. I used Llama 2 under the hood. But what I chose to do for this project was to only return matching chunks. So I did not even return a complete answer. So the value in here was just to find the correct pieces of information from all those documents. And the value add is, like, for example, if they just did like a search, right? Like, if they just did Control F, first of all, they're looking at one document at a time, and then also, like, if they looked for like happy, right, like, they would find only happy, but they won't find joyous. And that's the value add, like, because of all these LLMs, like, you all know this, that because the LLMs capture the meaning of the term, you don't need to know exactly the phrase to look for. It can find things that are semantically similar. So this was kind of the setup, and this slide is from deep learning. So you have these chunks and you have the vector store. And then when a query comes in, it finds relevant chunks, the top K chunks, and then along with the prompt and this context, that is what is provided to LLM, which can then give the answer. So I actually did not even display the final answer in this case, but these chunks that it found, those are what were of value. So I created a tool that looked something like, so these were the sources, and I'll show you the tool in a second. So the tool, the sources were the CMS documents, RCWs, which are Revised Code of Washington. These are state laws that our hospital must comply with. These are some of the documents that were picked by our team, and this was like hundreds of pages long documents, right? So this is what the tool looked like. So you can ask your question here. These are the documents that they picked, and I provided links to the documents just to make it easier for someone to use this, and they can just look at the documents if they wanted to. When they ask a question and hit find excerpts, what I return is link to the whole document. And when you click this link, it actually takes you to the appropriate page where you find the matching chunk. And I return the chunk so that they can look at, like I return top K chunks. So you can look through the whatever looks interesting for the regulatory compliance team. They can kind of then go to the source. So I wanted to make sure that this is grounded, right? Like you have a way to go to the source, and because we all know that LLMs can hallucinate. So this is kind of a way to mitigate that, to get directly back to the source. Uh, so for example, if you ask how should expired medications be handled, it'll pick different answers from different sources. So there is something in the CMS manual. There is also access to prescription drugs. There is also some reference about how drug samples should be handled, or expired samples should be handled. So all of that can just get directly pulled up, which just hopefully makes their lives easier. So any questions about this before we move on to the next topic? Yeah, I see a hand.
Maybe just one question. In terms of the splitting that you did to populate the vector database, is that a standard process, or was there anything special about what you did there?
This is pretty standard. It was already pretty standard by last November, and it is now for sure standard. There are different ways to do this. Different, like, so you can use, for example, different embeddings. Does everyone know what this process is, or would it help to kind of just go just a little bit into detail? So let me just kind of, in a few words, yeah.
I would be interested, but I don't want to waste it.
Oh, no, that's fine. That's fine. Let's just take like maybe a minute or so. So the idea is, so you have these chunks. So these are words, right? Like these are paragraphs or something. So you want to, is like computers can only handle at the end of the day numbers, right? Like they can do operations on numbers. They don't like really understand words. So essentially somehow you have to convert words to numbers. And that is the concept of embedding in the first place. So for example, you can just take like your whole dictionary, and you can do like one hot encoding, like just encode it as just one word at a time, and just create a vector that is the dimension of the whole dictionary. But then that is not necessarily optimal, because like first of all, your vector will be very, very long, and then you're not really capturing the this meaning of the words, right? So what is done is to create these vector embeddings. So for example, you take like all the words in the dictionary, but you train your model by trying to predict, say, the next word in all of your training data. And if you keep doing that, convert these words into n-dimensional vectors, but it's not one-hot encoding. So it's not like just 1 in one place and 0 in all the other places. These are true vectors, and each word is converted into a vector. And because you're training this by trying to predict the next word, in that process, your model has to somehow understand something about the meanings of the words. So, for example, I was very happy or I was joyous might occur in the same way. So it kind of understands that it needs to keep these vectors close together. It needs to somehow keep them similar, like, for example, by cosine similarity. So it learns those things. And once you convert this to vectors, then you can literally do like kind of math on it. And you might see like these equations like king minus man plus woman, the vector, if you kind of use the vectors for that, that becomes similar to the vector for queen. So what you're doing here is you're taking these splits, those are like paragraphs of words, creating vectors out of it, which are numerical things, and then you're creating a vector store. So these are all numbers that are stored, and because this is specific kind of data, there are efficient ways to store it. So then out of these vector chunks, using something like cosine similarity, again, that is kind of what's happening behind the scene to find these relevant splits. Yes?
So when I saw your word splits in the slide there, I assumed that to mean that the documents were cut into smaller chunks and not so much about the embedding, but more about that some set of vectors that represents a chunk of a document, right?
Yes.
The set of embeddings that are all of the words that are in a chunk of the document. So what I was more asking about was, is that a correct assumption? Are you splitting the documents into smaller chunks and then doing embedding of the content of each of those chunks, and then the vector database contains a retrieval from the vector database would return a piece of a document vectorized into the embedding?
Yes, that is absolutely correct. So just like, yeah.
So then what I'm asking is, how did you choose where to split the documents or how to cut up the documents?
Okay, got it. Yeah, so that is like, again, there are kind of semi-standard ways to do this. So you can choose, like, for example, how long each chunk should be, and you can choose how much the overlap should be. So you can experiment with that, and you can also like go with some like standard pieces.
Based with some overlap.
Sorry?
So it's basically size based with some overlap.
Yes, exactly.
Understood. Thank you.
Sorry if I explained things that you already knew. Okay. Yeah. Other question?
One more question about LLM. From my understanding, you have a vector database, right? And you kind of retrieve related documents to your search query. And where is the LLM part itself? Because like from your current slide, I'm not quite sure like where is the LLM magic happens.
So to my understanding, like just creating the embedding itself is a process, right? So just how do you make sure that the happy and the joyous come together, right? So that itself is training. That piece itself you need to do training to get there. So the creation of the embeddings itself has to have some training process. There is then there is this piece where you are also using LLMs. So you are using kind of this information, this training process in creating the embeddings, and then also in training, in then producing the final answer.
I think, can you go one slide forward again?
Sure.
Maybe one more when you were showing the app on Hugging Face. Yeah. So I think what the question was kind of asking is, you have that button that does find excerpts, that's doing the retrieval part, right? So it's giving you the chunks.
Yes.
And then after that, are you doing any additional processing with an LLM to summarize that? Or are you just doing the retrieval part and giving that back to the user?
So I'm actually, when I click the button, it actually also produces the answer. For this project, I'm just choosing not to display the answer to the end user to mitigate hallucinations issue, because for this use case, just providing the chunks itself was sufficient. And Ryan, right? So to your question, like, this is what the chunks look like. This is how big they are.
Yeah. Okay, thank you.
So I'm sorry, so the LLM is relevant to producing the chunks in what way? Because it almost, does the LLM produce the queries to the vector database, or are you doing that query first in order to, in a RAG kind of way, to provide the chunks to the LLM in the first place?
So this is RAG. So this is the piece that is relevant, this embedding piece, and that is what will decide which chunks get pulled. You're absolutely right that in the tool that I'm using, for example, if I changed this to change this from Llama 2 versus Llama 3, nothing that is displayed to the user will change. Only if I change this embedding will the user output change.
Okay, understood. Would you clarify then why it is necessary to run the LLM step at all if you're never even displaying the answer?
Yeah, I can do this without running the LLM step. The reason I did this was the idea was to then also wet the output, like kind of run a trial, show the answers to a select set of users, identify how accurate it is, and then decide whether we want to display it or not.
I understand. So ultimately it was extraneous, but when you were building it, you weren't sure.
Right, correct.
Okay.
Correct. Yes, yes. As far as what the users see at this point, it is unnecessary to run the LLM step. So we don't need really, we don't need this step. Just we are stopping, like right here, we are stopping.
Thank you.
Sure.
I have a, so you'd be getting, say, like the prompt in the output step, and then you'd be putting that into the LLM. I'm just kind of curious, like, how do you like format that query to the LLM? Do you like, I don't know, do you pass like the chunk from the retrieval in with the prompt, or is there any concatenation that happens there? Or?
Oh, so this step, right? Like, so the one that I'm not using now, but when it is used, yes. So there is, so again, there are, so under the hood, I don't necessarily understand all the steps, how this happens, but there are like literally functions that you can use that include the prompt and that include the references, the relevant references, and the name of the LLM. So I'm using the function. So I actually do not know under the hood how exactly it is happening, how exactly it is combining the prompt with the relevant chunks. I know that to that function, if I provide these pieces of information, it gives me answer. Maybe somebody else can answer this question better.
I personally, but I don't necessarily need to know under that. I'm kind of curious what the functions you're using, so that maybe.
And I can like after, so Ted, is there, I think this is on the meetup, I can maybe like, I can share some links because a lot of this was based off of a YouTube video that kind of walks you through a lot of the pieces, how to design this, and that comes with its code. I can also share my code. So that might help, like we can maybe dig through the rest of it together. Then I can like, we can get started with the function that I'm using. And if that is also in the public domain, we can kind of go through it and see exactly how it is doing it inside. So I'm happy to partner with whoever is interested in digging deeper.
So on that, are you using something like LangChain Is that what's
Yes.
doing some of that driving? Okay.
Yeah.
Yeah.
Okay, let's keep moving to the next one. I'm sure there will be more questions. So the next project was sickle cell for our sickle cell patients. So just to give you some idea, like I didn't know, for example, about sickle cell a lot before. So I want to kind of just give some background. So one of my personal motivations in working on this project is like I am very interested in health equity, and you may have seen this cartoon. Let's not go into that right now, but I feel it's important that we are in somewhat position of power to choose what projects we work on, and I think it is important that all of us kind of try to make an impact by using that power. The sickle cell anemia. So this is a disease that is underfunded. Research in sickle cell is underfunded. There are so it disproportionately affects patients of color. Uh, Almost all the patients with sickle cell, they have painful episodes called sickle cell crisis. The disease, it is a genetic disease, and it results in the red blood cells that are not quite working properly. So especially when they're deoxygenated from like working out a lot or from stress, they form this sickle shape, which is where the name comes from, and they get kind of sticky. So they can kind of clump together, which is, to my understanding, again, I'm not a clinical person, but that is kind of the root reason why they get these pain crises. And there are ways to kind of preempt some of this to some extent. Up to a third of the emergency visits are potentially preventable. So this project was with our providers, and to understand which patients are at highest risk of emergency room visits, and then to see how potentially we can have some interventions. So for me, the goal was twofold: to use traditional machine learning to build a predictive model. And then I also wanted to see if we can use generative AI to kind of augment that information to make it easier. Sorry, I just saw the question. Do you always get the same chunks when a question is asked? That's a good question. I don't know if there is a random number seed in there somewhere. We can look at it later. Let's see. Yeah, so the data for the sickle cell project, let's see. So we are trying to predict emergency room visits in next 30 days. That was the target variable. The source data, like the features that were used, were demographic features, clinical features like medications and labs, operational features, past encounters, reason for visit, number of emergency rooms in the last year or so. And the way I chose the cohort was all the patients with sickle cell disease were included. There's also something called sickle cell trait, where only one of the gene copies is affected, which is not same as the disease. So we restricted our cohort to the patients with sickle cell disease, and current patients with at least 2 visits in the year before the cutoff date. We did some exploratory analysis just to see what is happening. And this is kind of the motivation, and that is kind of something very rewarding in working at a healthcare center, because we had only 136 patients, small patient size, but each bar here represents a patient, one person, one human being. And this is one human being who is going to the emergency room 91 times in a year. So any difference that we can make here, it feels meaningful. A lot of them had over a dozen ED visits in the past year. On an average, almost 1 visit per patient, 0.67. A lot of patients are Black or African American. These are young people. More exploratory analysis just to take a look at this data. So these were reasons for visit care coordination, medication management, pain crisis, and so on. They have pain score, so they can. So patients are asked, "What is your pain score?" and this is self-reported. So to some extent, it is like somewhat reliable. You can compare like my score yesterday to my score today, but we can't really compare my score to your score. So we can take a look at this and kind of explore what's happening, because that can let us understand whether the question is being asked in the first place. If the pain score is high for a while and there is an ED visit, what's happening? Is there a way to intervene, and so on? These are labs. The teal are the ones that are low, the orange are the ones that are high, and the blue are the ones that are just abnormal. So sickle cell patients do tend to have low hematocrit and hemoglobin and so on. So these are some of the pieces that went into the model. So I did a random forest model. What I did was, like, for example, if there is reason for visit, right? Like, so that can be many different reasons for visit. And each of them then one hot encoded, right? Like became a column in itself. So I had like hundreds of columns, like and then kept the highest column. So like 372 columns, kept the top 50. And this is kind of what the columns would then look like: reason, visit, name, pain management, and so on. I did random forest model with 200 estimators, and surprisingly, this actually came out to be a pretty good model. In healthcare, AUC of 0.5 is actually considered pretty good. So we were very happy with that. But I wanted to go beyond this, because just predicting the patients with highest risk may not be quite actionable, may not be quite enough. So we have a model, but now what? So physicians are overwhelmed with the amount of data, with the amount of information they have. So we want to also ask, not just saying that, hey, this patient is at high risk, now you figure out what to do. We wanted to also provide some explainable piece to it. So I use Shapley values. The idea is to explain what is the driver behind the high risk. So it could be the cohort risk is here, and let's say patient A risk is here, patient B risk is here. Both the patients are at higher risk, but this patient may be at high risk because of, say, they don't have transport to get to the doctor. So they are only being seen in emergency room and not going to their normal appointments. This patient may be at higher risk because they have lots of other conditions like diabetes or hypertension. Right? So we want to understand what are the drivers behind the risk. And you can get to that through this Shapley values. The other piece I wanted to use was the unstructured data, which is the clinical notes. And that is why we warmed up with the regulatory compliance piece, because I'm essentially using the same tool here. So what I'm going to do here is to use patient notes. So in that project, we trained the model. We did these chunks out of the PDFs that were provided by the domain experts. Now we are using the same technique, but what we are using is the clinician notes. So we use patient notes for one patient and break those up into chunks and try to find the relevant chunks. So that is kind of the idea. So the tool that I built, so just to show you a mock-up first. So when you open the tool, it will kind of populate with the list of highest risk MRNs. And then the provider can enter enter an MRN. MRN is medical record number, which is identifier for a patient. So you enter the MRN here. Once you enter an MRN, now you picked a specific patient to look deeper into, likely from one of the higher risk patients. So then when you enter an MRN, some information about that patient pops up, like maybe their ED visits recently, what are the risk factors? And this is where I'm showing their Shapley values. So they are at high risk. Why are they at high risk? We can populate their medication list or something. And now this is the generative AI piece. We can have a way for the provider to chat against clinician notes. So this is the screenshot from an actual tool. Now this lived obviously completely within our organizational firewall. You have to validate credentials. So initially we just had like a username password, but then the idea would be then to link it to the organizational credentials. And this is kind of like what I'm showing you, of course, is fake data. When you open the tool and enter your credentials, this list of highest risk patients will pop up. You like presumably the clinician is familiar with some of the names. They might want to dig deeper into what is happening. So when you enter an MRN, then something like this will pop up. And this tool also I built it using Streamlit interface. So once you enter the MRN, then the pain scores, for example, can pop up. The ED visit dates can be shown. And this is the Shapley values piece. So what you can see is the feature. So for example, this is how much this particular feature contributes. And one can read it like the reason visit name no show is the feature. So they had a lot of visits that were no show. So no show is when patient just doesn't show up for the visit, so they don't cancel it. Somehow they miss the visit. And for this patient, like the way I was showing this information is the value for the patient and the cohort mean. So this patient missed 6 appointments on. Is there a question? Whereas on an average, it was 1 missed appointments. So then the clinician can dig deeper. So this is where the LLM piece then comes in. So behind the scenes, once the MRN is entered, what I'm doing also is to pick up the chunks for that particular patient. Right, so I have the clinical notes for that particular patient, which have been divided into chunks. I have created a vector store on the back end already. So I pick those notes which are labeled. So the metadata for that is the MRN for the patient and the date of the note, so that I can show that later. So when a clinician enters this question, now I'm only looking at this patient's information. And then one can pull again relevant chunks. One can like, again, you can either display the answer or not show the answer. So here I was like, for this case, I was working again with the provider and some of the previous questions, right? So this now uses the LLM. So I was working with a provider to again see how useful this was. So you can ask a question like, why did this patient miss appointments? How many appointments did they miss? So this is like, the hope is to try to make this information more actionable, right? So to try to see how one can help this particular patient. So then the tool will then provide an answer as well as the relevant excerpts. So again, I'm using RAG behind the scene, and this is labeled with patient MRN. That is how I'm pulling notes for this particular patient, and also the visit date. So this is stored in metadata for the chunks.
Sonali, quick
yes?
question.
Yeah.
So,
please.
did you do like hard database criteria so that only chunks specific to that patient could be returned? And then you used the vector search to actually match the query?
Yeah, so when I create the vector, the chunks, there is metadata that is associated with the chunks that I can filter on. So that is what I use.
On the patient MRN so that you made
Yes.
sure there's no approximate matching, like you are
Yes.
sure that these are exactly
Yes.
only the chunks for that patient, right?
Yes, absolutely. Absolutely. That is critical. You can't mix up. Yeah. So yeah, you have to have the metadata for patient MRN and the visit date so that I can then display it here. Because the idea then is again to be able to go back to the source, right? Like the clinician needs to know. So because when the way in Epic, so this just like, maybe thank you for that question. Let's maybe like go back a little bit, sorry, to here, sorry, I went through that. Where did it go? I had a slide on this. I'm missing it. had a slide on the Epic data. Oh, I think that's on the data one. Sorry. Thank you for your patience. Okay, this one. Yeah, so the way so this is Epic. So Epic has these data. So they have these chronicles, which is like live data. So when a clinician enters data, it is marked with the patient MRN and the note and so on. And then from there, it kind of goes into this data mart called Clarity, which is my source. And that the information for the MRN and the date still remains. So when I pull information from the data, I have that information that then I can feed into the chunks. So that I get that information on the MRN and the date that I can feed into the patient, into the vector chunks.
Thank you very much.
Sure. So we are very close to the end of the slides. So this is how you answer the questions. And then I again also just have this this tab here so that you can also just, since you know the MRN, you know the date, so you can just pull the full note for that day so that you just get a small chunk here. But if you wanted to take a look at the whole note, I just provide that piece here. They can also go directly into Epic and find it, but it's easier if everything is in one place. So this is pretty much my data set. So there is a lot that can be done on this, because this is like, there's nothing specific to sickle cell here, right? Like you can use essentially the same kind of tool for many other projects. So for this tool, like we wanted to validate, refine, improve the model, interface, we can make it so much better, widen the scope, not just sickle cell patients, but all of our patients, look at emergency department or emergency room visits for all of them. I just finished a leadership fellowship with Aim Ahead, which is an NIH endeavor. And they work exactly at this intersection of AI and health equity. So for that project, this is something that we were interested in doing. So technically, like right now, the way I've set this up, like this is proof of concept. Like we just wanted to make sure that this works, but this will not scale right now the way it was set up. So we would like to make sure that it scales. We can use better LLMs, and also I have not used agents here, which will be fun to do, because depending on the question that is asked, I can then pull, like agents can do a lot more, right? Like they can pull different, even discrete pieces of information, interface with other things. So there is a lot more that can be done. Very sadly, all of this work is like completely halted since last November, because we don't have the infrastructure to do this safely and protecting PHI. So I'm not able to move this work forward at this time, but those are the things that I would love to do. So I think, thank you very much for your attention. I welcome any further questions.
I have a very quick one. I'm just kind of curious, those bubble graphs that you had on one of your slides, they look really professional and awesome. And I was kind of wondering, what you used for them, like what tool?
Oh, which ones?
Yeah, like the bubbles of various sizes, where you were doing EDA.
Yeah. That is a Tableau. So you're talking about this?
Okay.
Yeah, this is Tableau.
Well, all right. Awesome.
Yeah.
And I had a question about your reg workflows. So are you able to, say if you have a couple documents and it can find it on like page 40, line 30, are you at that level of precision where it can like say in specific so you can explain what you're getting?
Yes, so I have so even in this project, so I have the page number. So like here, it finds that document, it finds the page, and in the PDF, what I do when I link it, you can like just do like that question mark page equals whatever, so that then it will go directly to that page. So when you click on this, it will take you directly, not just to that document, but on the specific page where it finds the chunk.
Yeah, I think that a lot of times that's enough. I don't think you have to go too much further, obviously if you have another LLM to verify that as well, but as long as a human can actually look at the page and say like, okay, I see it, and then that's good enough, and there's no other reason to explain it any further, I don't think.
Absolutely. And sometimes there is reason not to explain it any further, because especially in these kind of critical cases, right, like regulatory compliance is serious business. Like hospitals can get dinged, can lose their accreditation if they are wrong, right? So you do want human in the loop for this kind of use cases. So there was a very good reason not to display the final answer.
Now, how many RAG documents did you get up to?
So this one, they were like, I don't know, 25 or so. Like some of them were hundreds of pages, some of them were smaller. And this was last November again. So there is a lot more that we can do.
Oh, okay. Well, that's the biggest that I've seen. I run a bunch of these notebooks, but I didn't know. I've probably got up to 3. There's another one called Raptor that's really effective too that you might want to look into. And that's another like lane chain kind of thing. But yeah, that's pretty awesome if you're getting up to 25 documents and then you can pinpoint out of hundreds of pages of each exactly that. I'd say that's pretty good.
Yeah, actually, I mean, I don't know where you're working, and like these were not very big documents. A lot of this I was literally running on my PC, on my laptop. So you can do a lot on your laptop. So I will find. So this was a video by a YouTuber called AI, or the channel was AI Anytime, and it was about medical chatbot on your laptop or something like that. I'll find the reference and post it here. It was a great video. That is where I kind of taught myself from. And this was, you can do a lot. And this was again like 6 months ago. So now there are a lot more is happening. I see a question in the chat about what agents are. And that is like, okay, again, other people may know this a lot better, but like there is also the concept of functions or agents, which are kind of similar in my head. So the idea there would be, so for example, depending on the question that is asked here, right? So for this project, depending on the question that is asked, so how, like, why did the patient miss appointments? How many appointments did they miss? So like right now you can find information from the vector chunks. So there may be information in the patient notes that say that answer this question. However, there is also discrete data. So what the agents can do is they can look at this and then decide that now it is asking about appointments. So maybe I can go into the discrete table that has appointments data, right? That has date of appointment, status of appointment, whether it was completed or missed or something like that. And now I can pull information from that. So you can invoke that process, that flow. So that is kind of how these agents work. So you can look at the question and then kind of go in different directions. So to my understanding, that's kind of what is happening under the hood when you kind of use all these different tools on like ChatGPT or Gemini or something like that. You're kind of invoking, like it understands like that this answer now would be useful. Like it might be useful to use a calculator, for example, right? So you use a calculator tool, and if somebody understands the concept between the tools and agents and functions, like the nuances, if somebody understands better, please explain. But the fundamental idea in as I understand is that the LLM itself can understand that it would benefit from one of these agents or tools, and it would know to, for example, invoke a calculator so that it knows it can actually do the calculation. It can maybe run a Python code or something and give you the exact answer, rather than using it like its training to provide like what is 23.96 multiplied by 56.238.
Hey, Sonali, I think we have time for maybe one last question. I saw there was a question in the chat about grounding. So like if you ask something, you ask why did they miss appointments, and there is no information in the chart about why they missed appointments. Did you do anything to check to see, You can read the question in the chat. They may have
Yes,
worded.
yes, I can see that question. Yeah, so there are a couple of ways one can do this. Currently, I'm returning the top K results, which is which will do this badly because it will return top K results no matter what. Like the top K can be all wonderful matches or all very bad matches. It's just returning top K. You can do it in another way, which is where you put a limit on the cosine similarity, so you demand that it has to be at least this close, right? So that might work better. It will vary, like number of answers returned will vary, but then you can ensure that it is at least this good. And then you can also do more sophisticated things, like for example, as Kevin was saying, use another LLM to ask, hey, is this question similar to this answer, and then kind of ground it in that way. So we can refine it a lot more. I'll just very quickly address George's question. So we were using AWS before, but I don't know of the enterprise scale solution. So we were customizing this. It was sitting on AWS at this point.
Awesome. Thank you, Sonali. Now we will swap over. And it's lucky because there's a lot of overlap with the previous talk, so I can probably be a little bit quick. Share this one.
Oh, bottom left. Yeah. And then switch that.
And then switch to this.
That one? No, sorry.
Unless you have different.
Yeah, the whole desktop.
Yeah.
Sorry, I missed like the stuff right there and then. Yeah, just share the whole screen upper left, the default.
Did you have it open? Maybe here.
I think it might be on a different desktop.
Yeah. All right, perfect. So lots of overlap with the previous talk because I'll also be talking a little bit about RAG. So this paper was all focused on when should you fine tune and when should you use RAG. So I'll start just overview of large language models. So these are models that have been trained against huge scrapes of the internet. They've got big text understanding. They've got some knowledge, but the big limitation with this is that they've got some knowledge cut off. So if they were trained in 2023, they don't know anything in 2024. But then the other part of that is, since they're trained on the public internet, they have all of this understanding of stuff that's available on the internet, but then your company or your specific use case or your private data isn't something that it knows anything about. So if you ask it a question about your specific corporate policy on something and it's only stored in a private document, then it's not going to have any way to be able to answer that. So these large language models have a lot of information baked into them and they have a lot of language understanding, but they don't know everything. They haven't been exposed to everything, so they can't answer questions on all domains. Oh, yeah. Yeah, good point. So we already talked a little bit about RAG in the previous talk, so I won't go into too much detail, but basically you have this idea that you have some documents and then you probably split them into chunks and then you embed them in some way. And now you have this knowledge store that has a bunch of chunks of information that you want to pull from. And so the way you do this is you will take whatever query, so the user says, answer me a question about something, and then it will go look in the knowledge store and try to find the relevant pieces in order to give you the context in order to answer that question. So this diagram on the right kind of shows that process of taking the documents, passing them through some embedding model, and then you get a vector database. And then on the right side, you have the user makes a query that gets embedded as well. And then you try and find the vectors that are similar to that, and it returns the documents or chunks that are relevant to that specific query, and then you pass it to the LLM, and the LLM tries to answer the question given the information that it was given. And so this kind of plugs that hole of the model can't know everything, it can't know about your specific documents, and so you're trying to make a retrieval system that fills in that blank for you so that you can give it the context that it needs to actually answer those questions. So here's some of the different phases of LLM. So at the beginning, you have to pre-train them. So these models don't know anything to start, but then you do a big scrape of the internet, and then you just fill it up with a ton of open knowledge of the internet. Most people don't have to do this because you just take some off the shelf backbone. So you take Llama or Mistral or something else that's already available, and then you have a few different paths that you can take after that. So you can fine tune the model. So you can say, I'm going to actually change the weights and make it do some specific behavior. So you want to make it more conversational. You want to teach it about your documents. There's a bunch of different things that you can do with fine tuning. And the other path is you can make a vector database. So you can do embeddings of all of your documents, and then you have a knowledge store that you can pull from. And then there's this other trick that's related to the vector database called in-context learning, where you're giving it certain amounts of information. You can give it examples of the way that you want it to interact. You can do some advanced prompting stuff, and then you can make it kind of learn on the fly just by giving it some examples or context. So you can piece all of those together, and you can do a whole bunch of things with it. And the general idea behind this paper is, when should you fine tune and when should you use the vector database and the in-context learning? Because you end up with very different trade-offs depending on what you do. So fine tuning, this is just taking the model and saying, I have some data, I have some input text that I have, and then I have some output responses that I want. And then you're actually going and you're doing gradient descent on the model, and you're saying, I want you to behave and react in this specific way. So a lot of people have been doing stuff with LoRa and all of these other parameter efficient fine tuning techniques. So you can take some massive model, and then you have a slew of tricks that you can use in order to convince the model to do what you want more efficiently. But the huge downside of this is that if you train the model to do one specific thing, now you have this model that was able to do many, many things, and it's only able to do that one thing now. Because when you do the training, now you have 10,000 data points that only point to answer questions in this specific way. It's not designed to be this open model that can answer any question and do any task. So you'll get something that is optimized for your use case, but it might no longer be able to do all of the hundreds of other things that it was able to do as successfully. So the big question, should we fine tune or RAG? And it was a sentence right in the first section, basically saying it depends. So there's no best answer all the time. So the rest of these slides will just be saying like, okay, when is it better? When is it worse? Because it's not as obvious as you should just fine tune your model or you should just use RAG, because they kind of solve different things. So in the paper, they looked at 4 different domains. So they have open domain dialogue, knowledge grounded dialogue, task oriented dialogue, and question answering. And so these are all kinds of different applications that are somewhere on the spectrum of better to fine tune, better to RAG. But they found that even within those groups, it's different between which base models you were using. So it's really, really dependent on what exactly you're trying. So the open domain dialogue data set is pretty mundane. I don't think that it's particularly useful. It's just dialogue between 2 people, and it's just trying to get the model to interact kind of cordially. So if you look at this dialogue, it's just AB, and it's like normal conversation. It's not answering some important informational question. It's just, can you conversate normally, basically. So the knowledge grounded dialogue, this is a data set called Wizard of Wikipedia. And the way that this one works is you have some topic, and then along with that topic, the wizard is given the context of that associated Wikipedia page. or some other external sources as well. So like it's given the topic lifeguard, and then it's in that pool of lifeguard documents, and then they're trying to have this interaction where the apprentice wizard or the apprentice is asking some questions about these things, and the wizard is giving it responses based on the context that it was given. And so the wizard is trying to use that knowledge base in order to answer these questions, and then there's a bunch of different scenarios that they can go through to verify that it's able to correctly use this information to answer these questions. So the task-oriented dialogue, this is another set where it's got some very specific tasks that it's trying to do. So they've got a slew of these, and it's basically saying, do this, do that, and then it's given these different formats of, here's your goal on this thing, here's the input that we're giving you, here's the output that we expect, and it's trying to follow those directions in order to achieve some specific task. And then there's a generic question answering data set. And so this is a more common one where it's almost like trivia, where it's like, here's some question, can you retrieve this answer back? And this one is from DeepMind. So looking at just the different methods that they tried and the results that they got. So what they're really comparing is in-context learning versus fine-tuning. So the in-context learning is sometimes using that retrieval augmented generation. So it's trying to say, pull the top 3 documents that are most relevant to this specific conversation or query. And then they also tried out something different where they said, instead of doing the retrieval system, what if we just always gave it the correct chunk? So the retrieval system is always going to introduce some amount of error because it's not always going to get exactly the right chunk. It's entirely possible that someone asks a query and then it returns back certain chunks, and those chunks aren't relevant to the conversation that's being had or the thing that's trying to be done. And so they tried this other step where they said, okay, here's how much loss the retrieval is introducing, and here's what you would get if you just always gave it the golden, like, this is the specific document that you actually need. So they tried this with automatic evaluation, just basically saying, here's the model's response, here is the intended response, how is that perplexity? So they can just directly measure numerically, like how often is it getting the exact words correct. So this is a very punishing metric, because if it just answers in a slightly different phrasing or something else, it will get a terrible value. And so this is kind of what we see down here. So the in-context learning is just trying to give it the context and then saying basically, hey, answer the question. And the metrics for all of the in-context learning end up being, so lower is better in this context. So you can see that the fine-tuning across the board is significantly lower than the in-context learning. And this is kind of complicated because the fine-tuning shows up numerically better on this metric, but in reality, they looked at this more in detail, just actual humans looking at it, and the results look very different than if you just purely looked at the numbers. So that was the automatic evaluation. So they also did a section looking at human evaluation. So they laid out this criteria and they gave 75 people the criteria of, here's how you measure if the model was correctly contextualizing, if it was an appropriate response, if it was actually correct. And then they also had another section for validity. And so when they had these 75 people look at the responses of the model and then compare them to the truth, they came to a very different conclusion than what you would see from just the perplexity. The perplexity is just saying, like, you literally got the string correct, but that isn't necessarily the same as you got the answer correct. Perplexity, you could actually say, you got all of the words correct, except for the one that was actually the answer. So you can get a low perplexity and get the actual answer incorrect if you swap the wrong word. And so this is a more holistic way of looking at it, but it's expensive because you have to have a human actually look and judge and say, what's this the correct thing to do? So on this, it actually makes it much more muddy, because you can see that the in-context learning is showing up favorably on a lot of these different data sets and a lot of different metrics. So if you look at it on the open dialogue, the in-context learning is getting rated better on a lot of these. So if you look at the fine tuning, it's significantly lower numbers on some of these results. So just shows that it's very complicated to measure these systems, because if you looked at the previous one, you would just say always fine tune, that's just so much better. But then if you look at the actual human evaluation, it's a very different picture. Yeah. Yeah. So that's the complicated part. So they had ground truth that some of these models were trained on, and it's like, this is the answer. But then they had human evaluators go back and look at it. And so the human evaluators actually looked at it and said, there's some amount of error in this labeling, or we just don't like your responses. So yeah, I mean, that's the reality of most data, though, is if you actually look at it and review it hand by hand, you realize like a lot of this is messy, some of it's incorrect. And so it is interesting that they included this ground truth in the like, let's go have people double check this. And it does show that like this, given the gold knowledge, the LLM is getting better results than they claim the ground truth is, which is surprising. Yeah. Yeah, good question. So then one of the other things that they looked at was the hallucination rate. So this is just basically saying, we're giving these models extra context. Is it making additional stuff up? Is it actually using the information that was given to it? And what they found pretty much across the board was that the fine-tuned models are hallucinating way more than the in-context learning ones. And this kind of makes sense because the fine-tuning models were taught some specific responses to some specific questions. So they had a data set that was only 10,000 points or something like that. And then the model is biased to answer those specific questions. And the in-context learning one is this sort of broader model that was meant to answer many, many questions and many, many tasks. And it was just given different context and told, use this context. And so it's pretty eye-opening that the fine-tuning actually yields such a high hallucination rate, because it's become much more specialized and it wants to answer in certain ways rather than following the directions and the context that it was given. And that's everything I have for that paper. Any questions in the room or online?
Quick question online, for the human scores, higher is better, but for complexity, lower was better.
Yeah. So this is a percentage. So this 100% would be the ideal. Yeah. The gold, no, that's when they are doing that retrieval process. They have the one option, which is the retrieval system is going to try to find the 3 best documents for a certain query. But the gold knowledge is saying we're only giving you the one document, and it is the one that contains the information that we're looking for. So in theory, the gold knowledge should be blowing everything away. And we see that in some of the metrics, but not others. So like in this QA one, when they give it the correct context, it gets 80% instead of 35. So that one was pretty interesting to me, because you're seeing that the retrieval system must not be returning the correct context very often if it only gets 35. And then when you give it the like best document, it gets 80%. That means a lot of the loss is actually from the retrieval.
How did they decide how much to train those fine-tuned complex models? Because I could always train a little more or spend more resources on training, and then I get better results.
Yeah. So they in the paper they used LoRa, and they trained the models for 10 epochs, and they used early stopping based on some metric. So they split their data into training and validation, and then they said, here's what's the best it does on validation. So I don't think that they could have necessarily significantly improved the fine-tuning results, because they did kind of the best given the training and validation data that they had, and then whatever they got best on validation, they then applied to the test set. So maybe they could have done different hyperparameters and different stopping point than train for longer or something like that. But it seemed like their procedure was relatively rigorously validated, and so they probably did well on their validation and then didn't do great on the actual test set.
That's what everyone does. So
Yeah.
what we do on Sudo.
Yeah, yeah. They wanted to evaluate the typical workflow. Yeah.
Ryan, was there any discussion on the paper on providing the RAG with the gold knowledge versus retrieving it or no knowledge, and the golden knowledge performing worse in some cases?
Yeah, I was surprised by that. There's multiple points where that's actually shown. And there's also cases where you can see that no knowledge was better than any retrieved knowledge. So in some way, maybe you'd have to look specifically at the questions that are being answered, but it might be the case that sometimes the knowledge of the model is actually better than the knowledge that was given to it, which is kind of strange to think about. But if the model already knows about lifeguarding and then you give it some clauses about lifeguarding, but it's the wrong clauses about lifeguarding, that might actually lead it astray from giving it the proper outcome. But the golden knowledge one, I don't entirely understand how that's even possible, where it's like this one from no knowledge to golden knowledge went down 30%. That's strange to me. I don't know.
Just for me to understand these numbers a little bit better, are these averages across the entire data set, a subset of the data set, individual example? Like what is the size of the data we're looking at here? Like Todd, for example, is large, I think, in Q&A and KGD.
Yeah, so these are percentages based on some test set. So I don't know exactly the size of these data sets. We could dig in, and I have the links to all of these. So like this knowledge grounded one.
Okay, got it. So each data set has a training and evaluation set, I guess, a percentage.
Yeah. So like these ones saying that maybe it's only 965 dialogues, but it has multiple different back and forths. So yeah, the size is actually decent. So it should be in the hundreds or thousands for most of them. And it has its own training and validation set, and then they're measuring on the test set. So it should be fairly clean and rigorously validated.
Awesome. Thank you. I'll take a look.
And they also had some details in the labeling process. So they had 75 different people annotating, but they also had overlap between the dialogues that were annotated. So kind of just to double check that people were annotating reasonably, and they had, I forgot exactly what the number was, but it was like 0.65 or something like that. And they were rating it as strong agreement, but even that 0.65 is not amazing. So I wouldn't put too much fine-grained value into this plus or minus 15%, because there's probably some amount of disagreement between labelers anyways. But yeah, that's the way that it's done.
So there are many people that have asked here, on the way, and almost with dialogue something. So what's the goal knowledge? Is it given the context or given the context?
It's given the context.
Yeah. Maybe for the like a daily dialogue, right? That's daily, that's something we response, and then just like a targeting of words. So in that case, what's the knowledge?
In this one, that's actually skipped. So that's why we only have the we have the no knowledge one, because there's no external knowledge, but you can still do that process of I'm going to fine tune the model to specifically do that back and forth. Yeah.
So the newspaper, a lot is contract or with or kind of model state. Or internet of the given data set.
For the given data set. Yeah, so the specific data set has a set of documents that comes along. Trying to do retrieval out of it. Yeah. Yeah, so people have done specific RAG fine-tuned models, and so it would be something like this. So this is the fine-tuning that they're doing. They can, you could theoretically, instead of just doing a fine-tune on each, you could say, we have all of these different benchmarks, train a RAG fine-tuned on top of all of these together, and then you have sort of a generically RAG fine-tuned system. Some of the people at my company tried that and they trained some models for it. And it did okay, but it's not really any better from a model that has been taught many, many things. It's difficult to beat a model that is so broad in its knowledge and able to follow directions already. You can get very far just saying, strong language understanding model, answer the question using the following context. It will already do very, very well.
Hopefully, because they have good use of like small model and answer to be right, and then spend less computational resources on that one.
Yeah. Yeah. It's possible to one of the techniques back here, distillation. So that's a big part of some of these things. So at my company, we have a model that's just 1.8 billion parameters instead of all of the massive 7 billion, 70 billion models. And that's the whole point of it, is basically we have this 1.8 billion parameter model, fine tune it for these different things. And that's what they did, their fine tuned RAG model. And it does better on certain things, but you're still going to get smoked realistically by a 70 billion parameter model without doing any training on top of it. It's just difficult to beat. Yeah. Yeah. Yeah, that's difficult. But that's just the difficulty of scale, is it as these models get bigger and bigger and better, you can do stuff with the smaller models, but it's difficult to justify training a small model when you already have a model that does what you want and you can just use it with no additional effort. But it is the cost and the latency and the extra deployment headache and all of that stuff. Yeah, very difficult.
This slides the instruct tuning associated with user task-based harmony data. Would we do instruct tuning with private data?
Yeah. Yeah.
I don't understand why they put it in this like a pipe that looks like.
Yeah. Yeah. It can be public, it can be private. Either of them works, whatever you have access to.
It is fairly common to take a publicly pre-instruction tuning model and fine tune it.
Why?
If you want a chatbot, you probably are going to start with a pre-trained instruction tuning model rather than, so you would start with Llama 3 instruct tune rather than just Llama 3, because Llama 3 won't converse with you. It'll just, do completion. So if you want a chatbot, usually people start with something that somebody else instructs to, and then you can still fine tune it for your text. But you usually use that public instruction tuning first.
Yeah, I see about that point. So when you using people stop public order available order.
Right. So you do multiple fine tuning.
This considered instruct tuning also one type of fine tuning.
Yeah. So like when you use ChatGPT, it's already been fine tuned twice. So there's pre-trained, and then they instruct tune, and then they do the I don't know what you call it, but they do the RLHF to make it so that it's polite and not biased and not mean, and alignment. They do the alignment, right? So a lot of those big models have already been fine-tuned twice before you even do it.
Maybe I still do not understand the instrument tuning and the fine-tuning. What's the difference? Would I even instrument tune the model, like chat and from Llama chat?
Yeah.
And then could I continue to do an instrument tuning using my private enterprise data?
Yeah, absolutely. You're right. So today, most people do instruct tuning the first part, just using the same next word prediction loss, cross-entropy loss. Okay. So you're right. It's absolutely no different from task-specific fine tuning. It's no different than the pre-training. It's the exact same setup, right? So in that sense, it really isn't. It's just what data you use. You happen to use a data where it's like question, answer, dialogue. That's the only reason why it gets a special name. But you're right. It is really fundamentally the same exact kind of fine tuning. If you do RLHF or DPO, now you at least actually have a different loss function, so it looks different. But technically speaking, you can fine tune on any kind of text, whether it be instruction or specific knowledge. If your company sells airplane engines, you can fine tune it just on airplane engine facts. You can fine tune on anything. You're right.
Yeah, I mean, fine tuning will maybe identify private data looks certain way, right?
Yep.
So we need to add the instruct part, create a data set. Or maybe what's the difference between instruct and the fine tuning?
It depends on exactly what you're trying to do. So like the way that I split those two, instruct tuning is you have a base model that is just guessing the next word all the time. And now when you're instruct tuning, you're saying, don't guess the next most likely word, guess the word that I want back, basically. Guess the response that I want back. So you're teaching it to follow some instructions instead of saying, just guess the most likely next word.
For fine tuning, input, output, right? For the instruct tuning is like the output is to pair like another, maybe some singular for instruction.
Yeah. And you can have multiple turns back and forth. And the second part, the task specific fine tuning, the way that I was using that is more like if you want the model to do some specific classification, or you want the model to do sentiment analysis or something more specific. So the instruct tuning can be kind of any dialogue, just I want you to respond in this way. And the task specific is more like, I want you to do only this one thing. And then the model just can't even converse after that. And so if you have private data that you want to train it to specifically do some things, and you also want it to be able to still chat, you might have to do some merge between your two different data sets and say, here's some public data sets that teach the model how to use instructions and have conversation, and then you combine that with your data set and you can train it all as one big batch, and you get kind of the benefits of both.
Is it the same, for the instruct tuning and the prompt, the same or prompt?
Yeah.
Same.
Well, prompt tuning is a special technique of how you fine tune the model, and so you can do prompt tuning in order to do instruction tuning. They're not necessarily completely separate, but. So prompt tuning is a specific, there's a difference between prompt engineering and prompt tuning. So prompt tuning is actually a whole different technique of like finding the best prompt in order to get a certain reaction out. But that's like actually messing with the embeddings and doing a sort of fine-tuning approach. So prompt tuning can be next to like LoRa and full fine-tuning and stuff like that. That's a way of kind of manipulating the model. But then instruction tuning is more related to the data set, I would say. The data set that you're doing prompt tuning or fine-tuning or LoRa with.
And that fine tuning is on all the model.
Yeah.
So you are updating you know, the transformers and the MLP.
Yeah,
update.
but finally, you can just find the model there.
Walk through that.
Yeah.
Obviously, now it's very popular, so people are trying every possible
Right, yes.
combination.
It's also different strategies, right? One affects the model itself, and the other one is just like, let me frame the question in a way that the model understands. And then we answer.
Well, in general, like stuff is for the whole model, like for the whole data, but the fine tuning is going more specialized. Because we get more specialization, but this is for the updating the weights.
Fine-tuning changes the model itself. So it makes the model different from what it was before.
It's updating again after, because it's strong, it's just updated the ones. But instruct, I think it's the space. Instruct the model is just be updated the weights based on the general quantity. Based on the input and output.
And the model itself does not change.
The model is going to change in all of those. It's changing all of the ways.
What if you like with prompt? Then I'm not changing.
Right.
Just changing the question.
That makes sense.
Yeah, I think the future too is going to be explainability, because if you have these huge models and awesome answers, but they can't say how they got it and they can't cite the sources, I think it's going to be preference towards the vector database, where it's going to be like, okay, we found the answer. Here it is, you know, page 5, you know, line 30, that type of stuff, as opposed to like, especially in mission critical fields like, you know, finance and medicine, is that you can't just like rely on some response, even if it looks awesome. And you need to start off with something like a Llama, you know, 370 billion parameter or OpenAI 4.0. But I think that the field is really going to take off when it comes to the point where, say, like you get an answer, and Gemini is pretty good at it too. But it can go like line by line. It's like, I found this, you know, this specific page or this specific document, and then we have it, as opposed to like, you know, just like an abundance of extra parameters that has all this extra function and can do all these other tasks, but can't, you know, provide a reference, right? So I think especially for application, you know, moving past just Gen AI, is that if you have something specific that you're working on, you need, you know, higher levels of, you know, like documentation of where it actually got, as opposed to just saying like, we need to, you know, the next huge model is out on Hugging Face and these types of things. So I think like an emphasis on, you know, backing up the result that it returns to you. I think that'll be like the strong point with Gen AI, because that's explainable. If you can point to some other document and now it says, you know, this is for sure where it got this information, that is explainable AI, right? And even though there's issues with like the architecture and these types of things, as things shift towards, you know, more of this approach, then the other people that aren't signed up with Gen AI, they'll believe. And, you know, that's where mass adoption comes, is where everybody uses Gen AI. Like people will be using Gen AI on our smartphones this fall, you know, in many different types of devices.
Yeah, thanks, Kevin.
One more question. Maybe I want to ask you whether your application and your company. Do you guys find the new pumps spending helpful and compared with other?
Yeah, so at my company, we have an enterprise RAG solution that we take into a bunch of companies, and we help them upload their documents and process them and do all of the chunking and OCR and all of that stuff. So it's been useful in that regard because we've helped multiple companies kind of take off with using that technology. There's a lot of difficulty in just the little details along the way, like getting the OCR of the documents and making sure that it's understanding like this is a table and this is a chart and here's a pie graph, and then someone asks a question based on something and then the retrieval pulls in the wrong part because we chunked a table in half. That's very difficult problem in order to get all of those pieces correct. But a lot of people are excited about it and finding good use cases for it. But a lot of it still relies on having good retrieval, which we saw in this paper is difficult to do. Like if you're seeing that the retrieval is getting 35 and ground truth is getting 80%, that means that the retrieval was terrible. It wasn't getting the right thing very often. And then we're also finding that the actual underlying LLM that's making the final conclusion is also extremely important too. The difference between a 7B model and GPT-4o is massive. It might be 60% right versus 90% right. And so it's much more expensive, it's much bigger, but people aren't willing to have a outcome that is 30% worse or just hallucinating all the time. Or so that's been my experience so far. All right, thanks everyone. Do you have Zoom in a different desktop now?
Probably.